In the heart of the Pearl River Delta, China dared to build what engineers once called impossible. A $50 billion highway floating across the South China Sea, the longest sea crossing on Earth.
Welcome to the most ambitious sea crossing humanity has ever built. Today, we uncover how China conquered the impossible.
3 cities, 60 million people, separated by 6 kilometers of treacherous sea and one of the busiest shipping channels on Earth.
The biggest challenge wasn't the distance, it was the seabed itself. Soft mud 30 meters deep, like building on liquid.
Beneath these waters lies a swamp of soft sediment, a foundation no engineer in history had ever conquered at this scale. Over 4,000 ships pass through here every single day. A bridge alone would block them. A tunnel alone would cost too much. China needed both.
This region carries one of the world's busiest shipping lanes. The solution had to bend physics itself.
Add to this nightmare a region pummeled by some of the most violent typhoons on the planet.
Whatever China built here would have to survive forces strong enough to flatten cities.
We proposed something never before attempted, a 55-kilometer hybrid sea crossing combining bridge, tunnel, and artificial islands.
A continuous Y-shaped megastructure linking 3 cities with 4 artificial islands and 1 undersea tunnel.
We designed it so ships pass over the tunnel section while planes from Hong Kong Airport fly safely above the bridge sections.
The bridge had to navigate one of the world's busiest airports, with planes taking off every 90 seconds, just meters away.
The blueprint was so radical, even seasoned engineers questioned if it could ever be built.
In 2009, China deployed the largest marine construction fleet ever assembled. Over 15,000 workers across hundreds of vessels, 120 massive steel cylinders, each as tall as a 20-story building, were driven into the seabed to anchor the foundations. Beneath the waves, engineers fought a silent war against 30 meters of unstable mud.
The sea fights you every day. Currents, tides, typhoons. We learn to work with the ocean, not against it.
Every component, from steel girders weighing thousands of tons to prefabricated tunnel sections the size of skyscrapers, was floated into position. To connect bridge to tunnel, China built 4 artificial islands from scratch, in waters too deep and too soft for any conventional method. Over 1 million cubic meters of sand were pumped, layer by layer, transforming open sea into solid land.
We monitored over 20,000 sensors in real time, watching every shift in the seabed beneath our feet.
Each island took less than 1 year to construct. Engineers compressed what should have taken 5 years into mere months. Crews worked through monsoons, typhoons, and brutal humidity, racing to beat each weather window.
I'm standing on land that didn't exist a decade ago. The Chinese literally built this island out of nothing.
The tunnel was built from 33 prefabricated concrete elements, each weighing 80,000 tons, nearly the weight of an aircraft carrier. Each section had to be perfectly sealed against ocean water pressure, 40 meters below the surface. Aligning each section required millimeter precision, in waters where the slightest current could throw everything off.
We had only one chance with each section. A 2-millimeter misalignment, and the entire tunnel would leak.
Underwater divers guided each segment together, while engineers above tracked every centimeter of movement. The result is a 6.7-kilometer tunnel running 50 meters beneath the seabed, the deepest immersed tube tunnel in the world. Today, drivers cross beneath one of the world's busiest shipping channels without ever knowing they're underwater.
We are 40 meters below the South China Sea right now, and ships the size of skyscrapers are passing directly overhead.
3 cable-stayed bridges punctuate the route, each tower designed in a different artistic shape, each a tribute to Chinese cultural symbolism. The Qingzhou Towers, shaped like Chinese knots, symbolize the eternal connection between Hong Kong, Macau, and the mainland. The Jianghai Towers honor the rare Chinese white dolphins that still live in these waters, a reminder that engineering must coexist with nature. Each pylon required pouring over 30,000 cubic meters of concrete, in continuous shifts lasting 72 hours straight.
Each cable holds enough force to lift 1,000 cars at once. They're tensioned with millimeter precision, all controlled by computers.
Over 32,000 kilometers of high-strength steel cable were installed, enough to wrap around the Earth's equator. Together, the three cable-stayed bridges span over 22 kilometers of open ocean, creating one of the most photographed engineering symphonies on Earth. The bridge deck surface required a special asphalt mix designed to withstand intense Chinese summers and direct salt air corrosion.
Each one of these cables, just a few centimeters thick, supports thousands of tons. Engineering doesn't get more elegant than this.
15,000 workers lived on-site for years, in floating dormitories and coastal compounds, far from their families.
I haven't been home in 8 months. But when my daughter sees this bridge on TV someday, she will know her father built it.
Female welders made up nearly 20% of the high-altitude crew, performing some of the most dangerous work in modern construction.
My parents say I am crazy for doing this work. But every weld I make becomes part of history.
On any given day, 25,000 meals were served on the construction site, fueling history's largest civil engineering project. Specialized deep-sea divers spent thousands of hours underwater, installing tunnel seals at depths where mistakes were fatal.
Every mega project has a human cost. Workers gave years of their lives, and a few gave everything for this dream of connection.
Engineers solved the soft seabed problem with cutting-edge composite foundations, sinking massive steel cylinders down to bedrock 50 meters deep.
Engineers tested scale models against winds equivalent to Category 5 typhoons, ensuring the bridge could survive 200-year storms.
We developed a special saltwater-resistant concrete designed to last 120 years in the harshest marine conditions.
Every steel rebar was coated with epoxy designed to resist salt corrosion, doubling the bridge's expected lifespan.
During its first major typhoon, the bridge swayed exactly as designed, dissipating storm forces through engineering brilliance.
The bridge has over 1,500 sensors monitoring every breath it takes, 24 hours a day, 365 days a year.
An invisible neural network of sensors detects movements as small as 1 millimeter, predicting maintenance needs years in advance. Today, autonomous drones inspect the bridge daily, finding issues human eyes could never catch. These waters are home to fewer than 2,000 Chinese white dolphins, an endangered species under threat.
We worked closely with the bridge engineers to redesign construction zones around dolphin migration patterns.
Marine biologists worked alongside engineers, tracking dolphin behavior in real time to halt construction whenever pods approached. Within years, the bridge piers transformed into thriving artificial reefs, supporting hundreds of marine species. Engineers preserved over 200 hectares of vital mangrove wetlands, redesigning landfall ramps to protect these ecological nurseries. On October 28, after 9 years of construction and over $50 billion invested, the bridge officially opened to the world. World leaders, engineers, and ordinary citizens witnessed history as the world's longest sea crossing connected 3 cities for the first time. What once required a 4-hour ferry trip became a 30-minute drive across one of the great wonders of modern engineering. Every day, thousands of vehicles cross what was once impossible water, transforming the entire Greater Bay Area economy. The bridge created the world's first 3-jurisdiction border crossing, where Hong Kong, Macau, and mainland systems meet seamlessly. Macau, the world's largest gambling hub, gained instant access to 120 million potential mainland visitors.
I crossed the bridge in 30 minutes after a meeting in Hong Kong. This used to be impossible. Now I work in 3 cities the same day.
Hong Kong, long isolated by water, suddenly found itself at the heart of a unified Greater Bay Area mega-region of 70 million people. Fresh seafood from mainland farms now reaches Hong Kong markets in under an hour, transforming entire industries overnight. Families separated by water for decades now reunite weekly, redefining what it means to be Chinese in the 21st century. Logistics costs across the Greater Bay Area dropped by 40% within 2 years of the bridge opening.
This bridge didn't just connect cities, it created an entirely new economic and cultural ecosystem in the heart of Asia.
From cultural exchange to economic powerhouse, the bridge made China's southern megacity belt the most dynamic urban region on Earth.
At 55 kilometers long, this bridge is 20 times longer than the Golden Gate, longer than all major sea bridges combined. Japan's Akashi Kaikyo, once the standard of bridge greatness, would fit inside the HZMB more than 14 times. The Øresund Bridge in Europe used a similar bridge tunnel island design, but at a fraction of the scale and difficulty.
Nothing in human engineering history compares to this. The Chinese pulled off what we considered theoretically impossible.
The HZMB now stands as the gold standard, against which all future sea crossings must be measured.
The bridge ran billions over budget. Critics asked if any infrastructure project should ever cost this much.
Critics also point to lower than projected traffic numbers, questioning if demand truly justified the engineering expense. From environmental groups to economic skeptics, voices around the world questioned whether the bridge's symbolism justified its astronomical price tag.
But behind every controversy, there's an undeniable truth. China achieved what no other nation has even attempted at this scale.
Once you enter the tunnel, you descend 40 meters below the South China Sea, beneath the path of supertanker ships above. The interior is bright, well-ventilated, and surprisingly serene. You'd never know you're driving beneath the ocean.
Every kilometer has emergency stations, automatic fire suppression, and direct lines to surface command. We can respond to any incident in under 2 minutes.
From a high-tech command center, every meter of the tunnel is watched by hundreds of cameras and sensors, 24/7.
Massive ventilation systems exchange the entire tunnel's air every 6 minutes, keeping it cleaner than most city streets. 6.7 kilometers later, you emerge onto another artificial island, and the journey across the bridge continues. As night falls, the bridge transforms into a glowing ribbon of light, visible from space. Over 100,000 smart LED lights create programmable shows for holidays and celebrations. On Chinese New Year, the bridge becomes the centerpiece of one of the world's largest light shows, watched by millions.
I designed what the bridge looks like at night. It's the world's largest interactive sculpture, and I get to paint with light.
The future of the bridge is autonomous, with plans for self-driving vehicle lanes and AI-managed traffic flow.
The bridge is just the beginning. China plans an entire network of sea crossings, transforming the entire South China coast.
By 2030-55, we plan 8 more sea crossings throughout the Greater Bay Area, building on the foundation this bridge created.
From space, it looks like a delicate thread. From up close, it is one of the boldest declarations of human ambition ever attempted.
The bridge holds at least 7 Guinness World Records, including longest sea bridge, longest immersed tube tunnel, and largest artificial islands.
This bridge is now studied in engineering schools worldwide. Its lessons shape the next generation of mega builders.
Specially designed expansion joints allow the bridge to grow and shrink by several meters with the seasons, all without a single visible crack. The bridge is designed to sway up to 3 meters during major storms, dissipating energy through controlled flexibility. Autonomous underwater inspection robots crawl across the tunnel exterior, scanning for any signs of stress or aging. The artificial island walls are designed to break wave energy in calculated patterns, protecting the structure from even the worst storms. It started as a vision sketched on a single drawing board in 2003. Few believed it could ever be more than a dream. Construction began in 2009. At first, the open sea looked unchanged, hiding the foundation work happening 50 meters below. 9 years of relentless construction, 2,000 workdays, thousands of innovations, compressed into a single defining feat.
我把我的15年献给了这座桥，每一公里都是我灵魂的一部分。我是活成的工程师中最强悍的。
I dedicated 15 years of my life to this bridge. Every kilometer is a piece of my soul. I am the proudest engineer alive. Even the concrete itself is a marvel of engineering, a special formula that has resisted ocean salt for nearly a decade without showing wear. From above, the bridge reveals itself as both engineering and art, a sweeping line of human ambition drawn across the sea. Every night, this bridge becomes a beacon, visible from space, declaring that no challenge is too great. From models on a child's shelf to a real megastructure connecting 3 cities, ideas can become reality with enough courage and engineering. From space, the bridge is just a thread, but it represents the largest, most expensive, most ambitious engineering achievement ever attempted at sea. Every sunrise, the bridge welcomes a new day, carrying commuters, families, dreams, and connections